Okay, let's get started. I wanted to do this, and for anyone wondering, am I on here? Nice. Anyone wondering, like, oh, okay, cool. Why am I still streaming? It's Sunday. You're like, does this guy stream every day? Is he insane? Yeah. I mean, you know. Nice. So the stream's up. Ready to go. Okay, so you want to be a coder. And everyone in your life is like, you can't code. You're dumb. You're stupid. And I'm like, hey, that's all true. But you can still code. Even if you're the lowest, dumbest, weirdest, creepiest, stupidest person in the world. Simp, you can still code. And that's why Node.js was created. For the lowest of the low. Here's the only Node.js primer you need. The most basic. I'm just kidding. You're not dumb. You're smart. You're valid. Oh, I'm good. So here, I just want to go through, because I code Node.js a lot on the streams. It's what I use to web scrape to get my data sets. I've been using it for a very long time. Since like I was a kid, pretty much. And now I want to kind of show people why I use it, show you some basics on why it's actually not fully bad. JavaScript gets a lot of hate, but there's a reason why Node.js is really important today. There's a lot of stuff happening in AI and a lot of stuff happening in Python, but Node.js is key. It's key to full stack development. It's key to all these GPT-4, code me a website things. All these things are generating React code, which is built with Node, typically. And it's all this backends, Next.js, Remix, all these things are built with Node.js. It has now become the web developer, like, godfather almost. And here I just want to go through I'm going to start with JavaScript Basics very quickly. So if you're unfamiliar with JavaScript and all that, then this part's definitely going to be for you. I'm just going to quickly get my chat here. So if you're in a boot camp and you're like, hey, I don't know, Node.js is weird and they just keep throwing you frameworks and everything, I will explain everything very clearly. This is everything you need to know, okay? And if you have any questions, ask, but ask in the comments. I can address in another video, but for now, we're going to teach you how to code in Node.js. Okay, so first things first. So, very basics. Node.js uses JavaScript. So you can skip this if you're already 10x. So some JavaScript basics. So let's start up a little JavaScript file here. Okay. So let's go, and I'm going to start one. Let's just call this basics.js. I'm in the wrong folder here. Let's basics.js. Okay. And understand, if you really want to know some basics around Node.js and JavaScript, Node.js uses the V8 engine, the V8 runtime, and that's going to become important a little bit. For now, just know that the same JavaScript environment using your browser is most likely the same one you're coding in your Node.js environment. That's a big reason why Node.js is important if you're a web developer. It's all in the same runtime of the code that you have to use in your front end. Okay, well, I mean the same architecture, okay, for compilation of the language. I don't mean it's literally like like the front end code is different than the back end code. Okay, you have two runtimes under the same architecture. Okay, so now let's get to the basics. Let's run through this. So JavaScript has, if you don't know JavaScript, JavaScript is a fairly straightforward dynamic programming language. One of the reasons why that is important is because the types, the dynamic part here, is why we don't have to declare our types, which is why TypeScript is weird. It's like if you wanted to do types, use Golang or C. There's so many better languages than JavaScript that are static, that have web frameworks. It's like, just like, I don't even understand, like TypeScript for like big teams, I do understand, but if you're like not Amazon, I don't even understand why you use it personally. But lots of conflict over that. I want the flame. I don't want the flame wars, actually. Don't throw it somewhere else. But okay, it's a dynamic programming language. That means we can do things like this. I'll get to why I'm doing var in a sec. Not doing let and const yet. Okay. We're starting with the basics. Okay, so we have var x equals 1. By the way, this is assuming you understand what a variable is in general. So here we're storing a value in x, and we will log x. We're going to run through this really quick. So here I'm just declaring a variable and running it. Okay. And the way we execute this is we have, which you should do, you should go install Node.js on your computer so you can follow along. We're running Node, and we're executing the file. And here, as you see, it outputted a 1. So now we stored a number type right here. So let's do this into a variable called x, which we declared with var, which is generic. Okay, this isn't we're not saying int x here. We're saying a variable called x, and then so let's now execute the type number. So this is very important, and I'm not going to say this again. In JavaScript, 90% of variables that you're going to use are going to be objects. Everything else is going to be primitives, and these primitives are numbers, strings, booleans, null, undefined, and symbols. Let me write that out. It's really important because the foundation of programming, of coding, is types. It's data structures. And the types you build data structures with structures that have types, that have values associated with them. And I guess they have frameworks for how they represent data, I guess, or there are different ways to represent data. You know, we use numbers to represent numbers. Killed that one. So, but anyway, so we have primitive types, string, number, and it's very interesting because typically you have integers and floats. You have the different bit type for that. So you have like float 32, float 16. JavaScript, we just have number. Okay, this is for the really smart people. Just kidding. No, I kid. Most of the time, half the time about that. So we have strings, numbers, booleans, and we have null, and we have undefined, and we have symbols. You don't have to worry about symbols, but this isn't, I don't want to get too much into JavaScript, so I won't even touch symbols, okay? Just forget about that. But we have null and we have undefined, and that's really important. So null is you assign null to a variable, and it essentially means nothing. So it is a value that's associated with nothing, right? That you can define a variable to have nothing. Okay, that's different than an undefined variable. So let's do this. Let's log y and z. Okay, you see you have null and you have undefined. This is very important because you're going to be in your class, in your boot camp, and people are going to be like, oh, null, and they're going to say undefined, and they're not going to even know. The reality is null has a specific value that's separate than undefined. Undefined is something that's not defined. I didn't define this. Okay, I allocated memory to a variable called z. It's free memory. Nothing has happened yet. Okay, there's no references to be made here. Okay, or there's no references to any actual value to be made here. This is undefined variable. Y is defined to nothing. Okay, now let's do this. Let's do y equals z. It's true. Okay. So now we're going to get into conditionals. We'll go back to variables in a sec. So conditionals. This is a very important JavaScript basic. The equals is not resolving the types. It's comparing the values. I know it's very confusing because, okay, why? This is trying to find the value for each of these variables, and for y it's finding nothing, and for z it's finding nothing. But it's not comparing the types. Understand? These have two separate types, but they both are nothing. I know, it's confusing. Just accept that these are two different types, but they apparently have the same value when we compare it. So that's why we have equals to compare the types, which is actually a faster comparison. Okay, so this is false because null doesn't equal undefined, but their values are the same. Okay, so now let's get into, so we have strings where I can say, hello world. We were kind of assuming you know strings. I don't pay for Sublime because I'm not a simp. Okay, so we have x. Let's print out x. We can see we have a string. Okay, so now let's get into the world of objects. Var x. So remember, almost everything is going to be an object, and what an object is, and this is across all programming languages that are object oriented. An object is a mapping of properties. Okay, so when you're using Java or Python or these things, languages that have classes, which JavaScript has classes, but it's not at the same seriousness as Java classes. That's the best way I can put it, because JavaScript is it's a very loose object paradigm. It's a very simple object paradigm. And what I mean by that is so we can create an object here and call it, and we can say, oh, okay, this is like color is like red. And then I can say something like name Jared, age 26, and then I can log x. So here's something very important. So what I just wrote out is an object. Okay? People are going to call it associative array. They're going to call it a map. They're going to call it a ton of different things. This is an object. Those other things are true as well. Like this is an associative array, but this is going to be used as an object in JavaScript world a lot. This is an object with keys that have associated values, which here I'm just using primitive values here. And the object X is a collection of all of these values. Want to know something really confusing? Arrays are also objects. And this can be a lot of different things. I could do that. Okay. Now let's do type of y, and let's log type of y and type of x on 2 different lines. They're both objects. That's the type of both of them. It's insane. So what's confusing here, so what you have to understand is arrays and instances of classes, there's a lot of different, you'll see this in front end, like DOM objects, DOM elements. All these things are represented through objects. So whenever you're dealing with some sort of API, whether it's the DOM or fetch or whatever, you're dealing with in the world of objects. And arrays themselves are objects. Okay, and here's the best example of that. So the array has a property on the object called length. So let's log the length of the array. It's 5. So imagine that deep in JavaScript, just for now, for simplicity's sake, imagine that deep in JavaScript, there's an array with a length of 5, or it looks like this. They make an object. Let's just comment this out, just so you know I'm writing pseudocode here. They have an object representation of y, and they say give y, the y values are this 1, 2, and this is what you're gonna get. This isn't real code. This is what you're gonna get when you're gonna actually like log y specifically. It's gonna return the values. So this is almost like the constructor, or best way I can put it is this is just the value getter. I guess it's less so a constructor, but so here we have length, which is like 5. Okay, so let's just assume that they have an object representation of this array somewhere in the code, which we can get access to and all that. Like this is an object that we can see all the properties on this object. Okay, cool. So everything's an object except for primitives. All right. So that's really the basics on that side. I'm going to really quickly run through. We're assuming you kind of know about if statements. This is how you write an if statement in JavaScript. So we have x equals 1, if x is less than 10. This looks like C code a little bit. And then we can have an else if to say x is greater than 10. And which you do 2 ampersands, x is less than 20. We want to say x is between 10 and 20. And then else, so this would be x is 20 or greater. This would be x is 20 or greater. Okay, so this is cool. So x was 1 and we logged x is less than 10. So here, this is a basic if conditional. Snapshot this. We're going to move past this because we've got a lot of concepts to cover. So here we're going to run through, what do I have here? We run through objects and primitives. Oh yeah, loops. So we have 2 types of loops here. We have while loops, we have for loops, and we also have for each and array methods. We can get into that later, but for now, I'm just going to show you real quick. X is less than 20. X. And what's going to happen? I'm saying while x is less than 20 is a loop. Okay, so for all Turing complete languages, you need to have some way of doing Boolean logic. You need to have a way of doing loops, and I believe you need to have a way of storing values, so variables. I believe that's actually all you need. I might be wrong on that. Please correct me if I'm wrong on that. Anyway, so here we're saying while this condition, which is a Boolean, it's a primitive, while this primitive type is resolved, do something in here, and then restart the loop and start at the top, and then check the condition, and then do this again and check the condition. So what's going to happen? It runs it forever, and I break my computer, right? Because I really should be doing something inside the loop so that when it starts up again, it stops at this constraint. Okay, so now I can say it logs at 10, 11, 12, 13, 14, 15, up to 19. Cool. And then as soon as it was 20, 20 is not less than 20, it didn't log it, and this didn't run, and it broke out of the loop. You also have for loops. So we have for var I equals 0. I is less than 10. And then we're saying the thing we want to have happen at the end of the loop. And then we're going to log I inside the loop. So it logs 0 to 9 and it stops. So the for loop you're mostly going to see in JavaScript and Node, you're going to see a for loop that way more than you're going to see while loops. That's just how it is, and this is a fundamental loop that is really important for all the programming. You're going to see these 3 conditions being made everywhere. So the first condition, or this isn't a condition, this is an expression. The first expression right here is we're saying, and this only happens once at the top, at the beginning of this for loop, is we're executing I equals 1, and so we're creating a variable called I in the scope, and we'll talk about scope in a little bit, and let and const. And we're saying we're going to check this at the top of the loop just like it was in the for loop. This is our constraint. We're going to say, is I less than 10? If I is less than 10, run the loop, and this expression happens at the end. So after our block, that's what we're calling everything inside the curly brackets. After the block runs, it's going to run this, I++. So a little interview question, once I run this, what does I equal at the end? Like if I logged I right here. Knowing what you know, that I runs at the end of each block. Well, let's try it out. It's 10. It's not 9. A lot of people think, oh, it's 9 because it's the last one thing. No, what happened is it had to be 10 for this to stop. Okay? So it's a little primer for loops. So we're going to very quickly go through functions. You're going to be writing a lot of functions in Node. So there's a way, we're going to talk about declaring functions and function expressions. So we're going to declare a function called add. Let's actually, we can log it. X plus Y. Let's run add. And it logged 3. So we just made a function, just like a function in your math class, f of x. And our f of x, what it does is it takes in 2. It doesn't just say take an x, it's f of x and y. And with f of x and y, it returns the sum of that. So this is a sum function. This is a summation. Okay? And we have 2 variables. And then we don't actually return the result. So returning is the foundation of functions. Is you pass in arguments and it returns some sort of value, and we pass in 2 values that we are assuming are of the primitive type number, and we're returning the primitive type number. So I can document my code here, and I can say returns number, and I can also say this has, let's actually do and I can also say arguments are x, which is a number, and y, which is a number. So this is a way we're now annotating our code, and we're telling everyone who's going to come back, hey, this is how this function works. We're expecting numbers, and we're expecting to return a number. Okay? Did I just invent TypeScript? Wow. It's crazy. If everyone did this, would we even need TypeScript? I get it. I get it. Okay, so we declared a function. What this means, so there's a way of, you can have function expressions. So you can have this. Let's actually use this. Well, no, let's do this for now. So minus y. Let's actually log minus x and y, 10 and 4, and we should get 6. So here's the difference between, the main difference you need to worry about right now for function expressions and declarations is the function declaration. This is the declaration, and this is the expression. The function declaration is hoisted, and the expression is not hoisted. And what that means is, in the JavaScript, sound drunk, in the JavaScript world, in the scope of this, in the scope that I'm currently in, the function scope, which is the global scope here, I will be able to run the sum right here. But, which is above the function, but I won't be able to run the minus right here, because the expression, as this error says, wasn't initialized. Also, if you want to look at line number endings right here, you want to see this is on line 7. It's very important. So that's very basic. So the thing that the important thing to know here is expressions are run inline, it's parsed, and the function exists in the stack, in the whole stack. So whenever any line is parsed, you have access to the sum function inside the scope you're in. So let's talk about function scope. So you may see that I'm using var. So let's actually make a multiply function, and let's say const. Actually, let's do this. Check value. Let's say if, if x is less than 10, I'm going to create a variable, and I'm using const this time instead of var, and I'm going to say const result equals bad value. Else, I'm going to say const result equals good value, and then I'm going to return run. I'm going to return result. And let's run check value. Let's actually log it. Check value 10. And let's see what happens here. Oh, it says results not defined. And let's do this. Let's change it to var. Let's see what happens. It worked with var, but it didn't work with const. So part of the reason why that is const is scope blocked. So you can only use const and let. Const is a constant. Let is similar to var, where you can just keep redefining it. It's a mutable value, where const is immutable. Let which operates the same, is also scoped. And what that means is the block, so this if statement block, it only exists in that context. So we can't use it outside that context. So for something like this, we would say define it, declare it. We're not defining it yet. Declare it in the scope, and then define it so that the whole entire scope outside of this if statement, but in this function, so it wouldn't exist, result wouldn't exist out here. So in this function, it would be declared in the whole scope, but in the if statement, we'll have to define it in the if statement, and this one should be fine. Cool. So, what did we learn? This is the last time I'm getting into basic JavaScript. Okay? We learned about primitives. We learned about objects. We learned about conditionals and loops and functions. And we learned about promises. And we learned about conditionals with if statements. We didn't learn about promises. We learned about promises. We didn't learn about promises. Let's not talk about promises yet. I want to talk about asynchronous versus synchronous first, and then I want to talk about promises. Well, let's keep it here. So, one of the reasons why back into Node.js, it was a little JavaScript primer, back into the Node.js. One of the reasons why Node.js is so important is because of the simplicity around the I/O. In terms of server-side development. And I know that you can do asynchronous code in Python and a lot of different language, Go, you can do it in a lot of different things, but with Node.js, it comes with asynchronous I/O. And you could say you don't like that. The reality is it's a big reason why it's popular, is because server-side development happens to have actually, weirdly, a similar runtime execution as front-end development. So there actually is a connection with server-side development and front-end development, which is super weird. So, because actually that's not, so a little background, part of the reason why JavaScript is actually popular is because JavaScript is one of these languages that was created just for the web. So like the web had a lot of different plugins like Flash and all that, but JavaScript was the first language that was just used for the web. And one of the consequences of that is that it's very simple, but it's also actually extremely tied to how browsers render things. So one of the reasons why asynchronous is the backbone of JavaScript is because blocking code blocks the render cycle, execution cycle. And you'll see this if you do something that isn't asynchronous in JavaScript. You do something that requires a while loop with a ton of different execution that's just going to take forever, a for loop, and it takes forever, and it takes like over and over and over again. You're going to notice that and that happens in a script tag below something or in your body. You're going to notice that things start to not run properly. You're going to start noticing that the body isn't actually getting executed because it's blocking the execution. Okay, so, and that's really important. So one of the main important things about that is, when we're going to start seeing this in Node.js, is that when you start writing your API endpoints, you want to make sure that everything is non-blocking. Like you'll see me do things where I do fs write file sync and read file sync and all that, but that's just because I'm writing a routine. When you're writing back-end code, you want this non-blocking nature because you, and so what I mean by, let me see if I can get a graphic here. So let's get a graphic here. So non-blocking code, JavaScript, Let's actually get a graphic of single-threaded JavaScript. I don't make my graphics. I steal graphics because I'm a haxor. I'm leet. Let's see, is there actually a good, let's see. Oh, yeah, this is okay. This isn't bad. This is a foundational Node.js lesson here. We're not just learning about how to code, we're learning about how things work. Anyone can just learn basic things on how to code. We want to learn about how things work. And we're going to go on this core question to figure it out. So, like, I don't know where this graphic came from. All right, so here, this is one of the main reasons why people use Node.js and why it got popular is because it was so simple to get, very efficient request life cycles. I'm not saying you can't do it in other things. I'm saying it's very simple to achieve the bare minimum. I'm not saying that's good or bad. You may not like that, but that's part of why it's popular. And it's easy to write JavaScript. So the Node.js server runs, and typically the way other servers process requests is they're on the single thread that's running. Let's say you're running Python. You have a single thread. You don't have this event loop right here. You have a request go in. It processes the request, and the CPU is running through cycles processing the request. Oh, you start your programming studies today, Estenio? Hi. Well, I'm very glad that you're watching this because it's very important. Are you learning Node? Because this is very important for learning Node. Super important. So part of the reason why Node is important is because when requests, so take the Python example, the CPU is built, or the CPU is running the processing the scripts, processing the lines that are being parsed in Python in a way that it's very synchronous, that waits until the execution's done, so waits until the request is finished, and then it pops up the next request that comes in. Okay, so it's dealing at request by request by request, and it's waiting until things are executed, and then it tosses it back. That's the synchronous way of doing it. And that's actually not bad. And you'll see that when you have various workers, which we'll get into sometime, where you want to have a different worker, so you don't want to have many servers running, many processes running, taking up requests. You want to have some way to balance the requests that go to the worker, so a load balancer. But here, so when you're using Node.js, part of the reason why it's actually pretty good for at a low level, at an entry level, is because it's single threaded. So the one way to deal with that in Python is you create multiple threads. So you say, okay, how many CPUs do I have? I'm gonna have 8 threads running, blah, blah, blah. I'm gonna have a ton of different threads running, even if it is just like a few CPUs, and we're gonna run these concurrently, and you build a ton of frameworks on top of Python to make that work. Look into Python Twisted. Well, that's a way to do it asynchronously, but look into a lot of their documentation. We'll talk about how they process requests, and it's very intelligent. One of the things, the benefit of Node.js is because it's single-threaded, because this architecture that was built into JavaScript, because of the non-blocking nature of the browser, in which the browser has to be executing JavaScript in the back end so that the browser can keep rendering things. So it has to be non-blocking, and it's single-threaded because there's only one user on the page. That's why it's designed so simply. So that actually that works well in Node.js because you have this single-threaded process running and taking in requests, and every single thing happening in the request is running and ticking on this single event loop that keeps concurrently, not in parallel. is concurrently processing all these requests and all the functions within that request, and it's popping off the stack of that function and saying, okay, let's not just, if this script is doing something complicated like making a fetch request and requesting reading a file, then it's taking a long time and it's starting up all these asynchronous processes, it actually can keep processing other things. The CPU cycles never stop, and they keep running and popping things off and processing smaller things that need to get done. And it keeps ticking. The loop keeps ticking in order to get new requests and process them, because of the single-threaded, event-based nature of JavaScript, of Node.js and JavaScript. So when you're thinking why people use Node.js, think about the single-threaded nature of it and the event loop. Okay? There's a benefit to non-blocking code, but there's also a lot of drawbacks. So don't just think Node.js is great. It's just, there's benefits and drawbacks to everything, right? Cool. So that's a sort of basic primer to non-blocking code. Let's get into promises a little bit. So this is the last JavaScript thing we'll get into. So a promise, let's actually write a function here. Let's call this function, let's make a set timeout in this function. And this is my function to say log late. So I'm saying log something late, and I'm saying pass it the amount of seconds that I want it to log something late, and I'm running a set timeout, and then I'm passing the seconds. Well, let's just do milliseconds, and then I'm passing the milliseconds here, and I'm gonna say the thing that I want to log, and then I'm gonna log the thing right here. So I'm gonna run log late, and let's say I want to log hello world, and then I want to do it in 1,000 milliseconds. Okay, so let's do more than 1,000. You could barely see what happened there. Ooh, it's taking a long time. So it actually did take 10 seconds. Okay, cool. So let's log something after this line, but it's being parsed after the line right here. It just logged it before, and now it's going to take 10 seconds. So if I want to run something that's sequential here, let's do 2 seconds. One of the things you can do, so there's a lot of ways you can handle this. So let's say I want to do something after the log late. This is one of the drawbacks of asynchronous code. Set timeout is being run asynchronously. Everything that takes time outside of your current event process, so like the single thread that you're using, anything that's going to be taking more time, so that it can't just, each CPU cycle can't just tick and just process and keep going. It's going to be upgraded into an asynchronous call. Set timeouts are upgraded into asynchronous calls, and the ticker in the event loop is like, this is like taking a long time, let me do something else, and it does this console log. So what I want to do is I want this console log to happen after. So what people do, and what people have been doing, is they've been writing callbacks. So here I'm going to get a callback, and a callback is a function you're passing to this function so that it executes wherever you want it to execute. People typically make it happen after the fact, so after what they want to have processed. And I'm going to write an inline function. In this inline function, I'm going to log another thing. So now I'm saying, instead of logging another thing right after, I'm going to put it in a function and then log it in this callback. Cool. So it actually did it after this time. But as you can probably tell, what happens if all of a sudden I want to have a callback within this callback, and I want to have, and this callback itself has more callbacks and more callbacks and more callbacks. Eventually your code starts to get, you start to get into callback hell. Look that up. I don't want to get too into it. I want to get into the node pretty soon here. So one of the things, the ways to address callback hell is using these promises. So a promise is a way of saying, so let's, instead of returning the timeout, we're going to turn a promise and the promise gives us a resolve function, and we're going to execute a resolve function here. So then now let's actually log console late so you can see what's happening here. It logged a promise that says pending. So what that means is this class has a state that's pending, and I want to actually wait until this is fully resolved. So there's a couple ways I can do that. So I want to wait for this resolve to happen. I can run a .then function, which is a way to wait until and then when the process is resolved, and I can log another thing right here. Okay. Cool. So I'm logging another thing here. So one of the benefits of this whole thing right here is we're able to sort of wait until something finishes and then log something here. So now we get into async await. And you've seen me probably do this on other streams where I have a run function here. And I do this mostly because I can run async await without doing it just inline. So here, async await is a way for you to not do .thens and just say, let's run this code synchronously by just waiting for this to finish and then logging. So now if I run this, it should run hello world and then another thing, and we're done. And now we can actually get into I covered promises, so we can actually get into some Node.js. Okay. So we talked about asynchronous versus synchronous. We talked about multi-threaded and single-threaded. So now let's talk about the V8 engine. So one of the reasons why, so Node.js is all around you. If you do React, you do Node.js, you don't even know. One of the things about V8 engine, which is super, or one of the things about Node.js which is super valuable, is the V8 engine. So the V8 engine, which in 2009 when Node.js was created, they decided to use the V8 engine, and that was such an important decision because one of the cool things about the V8 engine is it's browser independent, it's runtime independent. So now you can use V8 engine in your browser, which is used in Chrome, and you can also use it in Node.js, and you can use it in Dino and all these different things. And V8 engine is incentivized for people to work on it to make it better and better. It's already like the fastest JavaScript compiler. That's what this is. It's a JavaScript compiler. And that's really important because now this powerful compiler is used in a lot of different places for a lot of different reasons that matter. So it's browser independent. So now let's get into the code. So this is a basic server Node.js. Let's walk through this code. You're in your boot camp. You're like, I don't understand what's going on. I gotta make things work for me somehow. This is the most important thing to understand about Node.js. Node.js is a JavaScript runtime that was made for the intention of building servers in a single-threaded, non-blocking fashion, which we already talked about a little bit. So first, let's go this line by line. This is the most basic Node.js script you can write to create a server for you. This used to be like 1,000 lines of code. Here we have like 14 lines of code. Many years in the make. So here we use require, which is a way to resolve modules. Okay, whenever you see me use require, what I'm saying is give me a module, give me another script, and put it in this script, and then put it in this variable. And we'll get into node modules in a sec. We have host name. So the host name is localhost here. 127.0.0.1. The local host is your local server host name. The port is the port. It's another part of the URL. So let's run this. Let's run this server. Actually, I don't think I have the server in this file. So let me touch server.js. It's a way to create files. And let's go and node server.js. It's telling me server's running at, and that's this line right here. It's giving me the URL that my server's on. Let me go type in this URL, and it just logs hello world. That's the worst website I've ever seen. It's the worst website I've ever seen. That's not going to make me millions of dollars. It's not going to get me gold. Ugh. Okay, so really, let's walk through this line by line. So we went to port 3000. Every HTTP port is on 80. Typically, when you're on when you're browsing around, you're on port 443, which is the HTTPS port. So when you go to YouTube, when you do whatever, you're going to be on the 443 port. Okay, so, and we set header. So what's happening here is the Node.js is really cool because they give you so much stuff. They give you create server, which is the foundations to the HTTP protocol. File library here is they give you this master suite of HTTP methods, HTTP related methods, so you can build servers from the ground up. So here we're literally just saying create server, and this is creating us an object that we can bind to a port, which is this test port we're using 3000. In the live production, you're going to be using 80 or 443. Here we're saying resolve to the port 3000 on the host name localhost. We could also just use localhost here. We're using one. This is the basic. You're going to be writing this port down a lot if you're writing servers. And it has a status code 200. That's a success state. So you don't see that a lot. You see 404, and that's how when you think about HTTP methods, you think 404, but 200 is the main success state. A redirect is going to be 302 and not 304. So we're setting a header, and in HTTP, so let's go through a basic HTTP primer here. Very basic. So HTTP is the protocol for how text is transferred over the wire. So whenever you go to any website, it's communicating using the HTTP protocol. We're talking with the English protocol. Okay, that's the best way for me to explain it. It's the language for which we transfer information on the web. Hypertext transfer protocol. And it has methods. So the same way when I communicate to you, I'm communicating to you with a certain amount of, I'm communicating to you in, I guess, what's a good way to put it? In sentence form, paragraph form. No. Actually, this is a better way to put it. When I say I am right now, I can choose to yell at you, or I can choose to speak calmly, or I can choose the method in which I'm going to communicate to you. That's the same thing here. So the methods in HTTP are the type of message we're sending. So we have get, we have post, we have delete. I should do put before delete. We have put, we have delete, we have option. A few more, but we'll just talk about these. So get is typically going to be used for reading information. Post is usually going to be used for creating information. When you submit a login, you're posting. When you submit a put, you're putting, so you're updating. You're updating information. Delete, pretty clear. When you delete your Facebook account or whatever, you're making a delete request. And then option is this kind of variable thing that you're really going to be it's going to be used in a lot of metadata type requests. That's how I've seen a lot of people use it recently. So that's sort of a basic HTTP thing. And then the HTTP has headers. And the headers are important. So one of the most important things about headers is that headers are, they're all the meta information about the request. So the stuff that isn't the body is another part of it. So the headers is all the information about the information. So here we're telling the browser we're sending down plain text. That's why it looks so weird. You're not even used to seeing this. You're used to seeing HTML pages. So we're going to tell it to encode our content type in HTML, and we'll see if that does anything. You see how it's a white background? So our browser sort of understands to render something of a content type content type plain in a certain way, and it renders content type HTML in a certain way. Okay, so and here we're ending our response. That's what RES. So in Node.js, REQ is going to be your request, and RES is going to be your response value. REQ is going to be the request that's what's sent up, and RES is going to be the response that's going to come down through the client, right? So here we're saying whenever someone hits our server at this port, send down a response that's encoded with the status code 200 with a header that's HTML, and then send down text and the response, and send down text in the body that's hello world. Okay, and notice that there's request headers and there's response headers. Okay, so it's very basic script. So now let's get into, where was I just at? Now let's get into the fun part, which is NPM. So NPM is an important foundation to Node.js. NPM acts as your module fetcher. So this is what you use to get modules, to get new things to install, to get like, so if I post a framework that's easier to use than that, because that can get a little complex, what we just looked at, I'm gonna submit it to the NPM, which is it's a service. You can go to NPM website and look at Node modules, and you're gonna be able to store your package on their fleet of servers, and it's gonna be in a distributed fashion stored all around, and I can say npm install that package and then run code. So here I'm gonna run npm init, and it's gonna give me some options here. So first it gives me, I'm gonna say primer. Let's say version 1. Description, this is all you need for Node.js. Entry point basics, test command, git, repo, keywords. So these are all, okay. So they were just asking me a ton of different questions for how to create the script. Your package.json is holy. It is a holy configuration file. It is the center of your world. Your world begins and it ends with package.json. Everything you need is in your package.json. Your package.json is how you configure your Node.js project. Let's walk through this. So you have your name, you have your version. Your version number is important because this is what other people are going to pull down when you submit your NPM module. NPM allows us to all share code with each other, and we can all install our packages and code really fast because I don't need to start from scratch. I can go install this module from the other world, you know? So, and I have my main.js. This is saying this is the main file that I have, which we can make it my server file. And that's important for, and then we have our start script, which is, so we have scripts, which is a part of the package.json that renders or that registers certain bash or whatever command line tool you're using, certain commands to execute in your command line. And when we run npm run start, which is the start script, it runs our server code. See how that works? And then when we run npm start as a shorthand, it runs it. But just npm start and npm test are the two shorthands we have. Then we have author, which is me, so I'll just put down my name, license, MIT, whatever. Okay, so this is our official, we don't have a license. This is our official package.json. Cool. So now let's actually install something. So let's install Express. Probably in your boot camp and you're like, what's Express? Well, I'm gonna tell you what Express is. Let's install Express. Let's go to the Express doc so I can give you an example. And I don't have to write it from scratch. Who do you think I am? I'll write from scratch. It's not 10x. Always copy paste. Oh, it's still installing. Waiting for installs is better than waiting for machine learning things to run. Okay, so let's touch server. Let's say Express server. Or let's call this one app.js. Let's paste our app.js. Okay, so what's going on? What's going on here? There's a couple things happen. One, a package lock file just got created. What the? This has so much. This is like has so much stuff in it. Okay, so it has a lot of stuff in it because of reasons that I don't know. No, I'm kidding. So, what the difference between your package.json and your package lock is your package lock is actually important. Your package.json, it's everything you need, but it's also not that important. The package lock is important because it resolves the packages of the packages. It resolves the state of your project. It's like a snapshot of all the packages you need in their version. Notice how I didn't npm install accepts or any of this stuff or mimedb. These are Express packages. These are all the things that Express needs and the dependencies of the dependencies. And then it flattens it and gives us this big file that tells us all the versions and the node and what node version that we need to run it. It has this integrity hash, SHA hash which is a security measure for us. And this is important because when you start sharing your project with other people, you're going to want to send your package lock up so that other people can install and know exactly the packages you had and the Node engine you had, the Node version you had, so that they know that they have everything you have. It's way easier for you to debug than to just say package.json, because if they just get Express with this version and they just get the package.json, they may be doing a ton of different, each of those individual npm packages may be doing a ton of different things to say, if it's on a Mac, install this version, or do this or do this. There's so much chaos around without using the package lock. It may be like, hey, we only need this version on this type of computer in this Node packet or this Node version. Okay, so you actually don't just need this. You need the package lock. Okay, so let's get into Express. So why are we even installing Express? What's the point? Why does Express matter? Like really, like why does this even matter? I'll tell you why it matters. So Express matters because writing server code without a framework sucks. Try it. Literally go, it's in C, write C code, write a server from scratch without a framework. Try to write your 10x, Facebook, awesome, ninja code. And then ask me how I'm doing 5 years from now. And I'll be like, oh, my life's great. Yeah, I'm like, everything's doing good. I have like I built like 1,000 things. And I'll be like, what are you doing? And you're like, I think I'm almost done the login page. I'm being dramatic, but yeah, it takes a long time to write without frameworks. So frameworks are important. One of the reasons why frameworks are important is because they're extensible, and the same way NPM extends Node.js, Express is extensible to the server architecture. So there's middleware, which we'll get into, and people make middleware that makes it easier for you to use your Express package. The same way people create Django and Ruby on Rails packages and all these things, and Next.js packages. Middleware, I can't even say it. Okay, so as you see, this is kind of the same thing, right? I'm just requiring this. I have this port. I'm saying on a get request to app on the base endpoint. So now we're introducing routing. Routing is defining your paths. So it's everything here is the route. I'm saying on the root route, send down hello world and listen to port 3000. So let's run Node.js. Let's go on port 3000. Why am I doing this so late? I'm so crazy. You see that it automatically returned it as HTML. That's cool. So nice. So we're done. We're cool. We don't have to learn anything else. What's the next thing? Oh, I'm kidding. Obviously, we're gonna have to learn a lot more about Express. Okay. So let's talk about middleware. Let's get a basic. Actually, let's just write one here. So the importance of middleware. The importance of middleware is middleware is so important in Express. It's like if you don't know middleware, you're just like, I'm not going to talk about Docker. No, actually, I will talk about Docker, just because you said I'll talk about Docker. So one of the most important things about Express and about any server framework is you have the request lifecycle. The request lifecycle is such an important concept to understand when you're trying to optimize your code or optimize your servers. So see it as whenever the client makes a request to your server, that little document we were looking at earlier, whenever a client makes a request to your server, they're sending up a request that has an associated metadata. It has headers, it has the body, it has whether or not their user credentials are there, it has their cookies, it has all these things. And it's up to you and your server to look at each of these things and do something with it. And middleware is a very good way to control the data flow and to go in our Unix philosophy and to enter with interoperability, do functions and pipe them together to say, hey, if they send up cookies, I'm going to add a middleware to parse the cookie. That's just a function. Maybe I have a cookie parser. Obviously, I'm just making this up. And app use is how you initialize middleware. So I'm saying before I get my endpoint, if you ever hear endpoint, this is the endpoint. The endpoint is the last line, or it's the last thing that happens in your request lifecycle before the response happens. It's that route that returns the response. That's the endpoint. And here we're saying before the endpoint we have a parser that's acting as to look at the cookie and do stuff with the cookie, and then say, okay, take out the information in this cookie and then do stuff with it, right? And we can also have a form parser. So let's say you have form data as well, you have binary data, and I want to do something with that binary data. If I don't want to do that every single request, I'm going to say just isolate this to some function called form parser that actually or maybe it's called get file data. And here the middleware is going to look at the file data that the user sent up, and it's going to say okay, parse it in some way so that I can have access it into my file endpoint. This is a way to abstract different routines in your code and then register them and then have access to them in your endpoint, or do a ton of things. You could even have so one popular middleware is auth. So I can say for all my protected endpoints, and by the way, I'm making up these functions here, but I can have a middleware that says before I hit my endpoint, check if the user's logged in. And if they're not logged in, send down a response. So I can have middleware here that's and let's say I have a session. So if my session user exists, so we can get into sessions a little bit. If my session user exists, then cool. Then next, actually I'll get into next. And then else, return, remember we use res end bad, you're not logged in, you suck. So here we're sort of saying we're checking if someone's logged in, and we're saying next. And what does next mean? So in Express, whenever you see next, what that means is go to the next middleware. Go to the next. So they have in Express, they have a sequence of functions that are running. So each one of these .uses and .gets are all happening in a sequence, and each one is piping to the next one. And the way it pipes to the next one is it's running next. I'm like a child. But it's running next, and the next is going to the next request and going to the next request until we hit the end. And here I'm saying don't do that, and end the request and send down a response. So whenever people talk about middleware, understand that these are the things that happen before your endpoint, between the client hitting the server, after that, and all these things happening on your front end until your endpoint. It's really important because you're probably going to be in your boot camp and they're going to be talking about middleware, they're going to be talking about Express, and talk about all this stuff. They're going to be like, set up middleware to do auth with the JWT token and then do all this stuff, and you're going to be like, I don't understand that. It's because you don't have the fundamentals. So the fundamental is middleware, which is a generic concept in software. Okay, it's a generic concept. It's something that is software in between software, in between the user and you and your server and your back-end logic. So your middleware, our middleware here is a function that we just wrote that checks if the session has a user. So the user sent up a request, and we're going to check if that user's session exists. So if they're actually a logged in user, and then we're going to say, yeah, okay, go along. You're allowed to make a request. Or denied. You're denied. You suck. You're not logged in. You're not 10x. So that makes sense, right? Okay, so middleware is super important because most Express packages you're going to get are just going to be middleware. It's going to be for, so like there's Express middleware for file uploads, right? So this is a very popular middleware. Very popular one right here. So this one is like, let me show you how this one works. And remember, you install this one with, I can just run this npm install command and I can get a file uploading script. So you know when you're applying to your junior developer job that you're not going to get, and just kidding, you'll get it. But you know how you're applying to that and you click to upload your resume? This is what happens on the back end. People get this file uploading script, and then they say, okay, accept, let me add some middleware here to accept all file uploads. And so I would have to actually import file upload. So they probably have some, hold on a sec. So I would have to say const file upload equals require express file upload. So I'm saying, here's my file upload, and now register, after I initialize my app in this function, I get an object, use the file uploader, and here are, and I'm saying, you know, limit it, the file size, blah, 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 50 times 1024 and all that. And what this is doing is this is going to allow us, let's say this is we have an endpoint that's like a post request to the endpoint upload. I can say here, req.files. Whatever the name is in the front end. And this is going to give me the binary code to this file. And if I have fs, which is a file system standard library that we get in Node.js. So if I have the file system here, I can say fs.read file stream this file. And I could say maybe, you know, my file or whatever. I can read this to a file. And let's actually go to, because I forget the API for this. So let's actually go to read file stream. Let's actually go to file system is really important. You'll see me use it a lot in my videos where I'm data scraping. Use it, but so like There's a reason why. Oh wait, it's not. It's a read stream. My bad. But yeah, create read stream. Here's actually a really good reason why we use create read stream. This is important. Well, we can just do this. This is really important, and they do it in a set timeout. We don't have to do that. And let's just do that. So this is sort of this is very rough. This isn't. Oh, I meant to do a create write stream. My bad. This is really rough. In fact, let me just get you an example so I can give you a good, show you some actually how you would store this file. Yeah. There's also a reason why people would, let's assume, and this is very rough because we don't really know what type of data we're getting from the front end. That's more part of the headers. So one of the reasons why you typically want to run write streams is back to Unix philosophy stuff. So in terms of I/O, Node.js is input-output. Node.js is made in a way that streaming and piping data is a part of the way you should be running your I/O. That's part of it's non-blocking, right? So you want to be opening up pathways to files and writing to those files in that stream, rather than loading up a file into the process and then reading it and then writing the data, stopping the process of the CPU cycles, deal with writing the data and nothing else, and then stopping it. So that would be like fs write file sync. If we did that right here, we could also use write file asynchronously. That's actually totally fine. We don't have to do streaming here. This is just a basic file upload. If we wanted to do streaming, we could say get our file in chunks and then chunk it out, and then as we get chunks, create a stream and keep writing those chunks to the file. But here we're just saying, we don't have to put this in a variable, but we're saying, okay, write to the file. And remember, we get this file's value from our middleware. Our middleware is giving us, when this function runs next, it's giving us req.files variable. And now we're saying write this file in the synchronous way, and then now our code sucks, and if we get, and now some little kid can DDoS us because our code sucks. We're getting we can get DDoS now. Look at that, we suck. Now we're getting DDoS. So why does our code suck right here? Because this is extremely dangerous to the foundations. It's not, it's not a gun. Now, people are the dangerous ones. It's not a crackhead. But it's dangerous to our system. And the reason why this write file sync is dangerous is because it's back to the non-blocking thing. This is blocking code. This is a single-threaded application. That means that as soon as anything blocking happens, nothing else is happening concurrently. So never, ever, ever write blocking code in your post requests. You can resolve resolving promises is actually a little different. And I can get into that some other time, but never do this. Never do Even async await isn't great. Never do while well, obviously don't do while true, but never do while x is less than 1,000, whatever, x plus plus, never do that. Never do these blocking operations, because you're going to be in a situation where everything stops and all the other requests that happen are going to have to wait until this file gets saved. And what happens if I DDoS this and I make 1,000 requests? You understand? So don't do that. So that's a little primer into the request lifecycle, into the non-blocking nature of Express. And yeah, so like overall, there's a lot of concepts with Express that really matter. This is just basic stuff on JavaScript, Node.js, and Express. There's a lot of different standard libraries. There's so many things you can do. You can build Facebook, you could build APIs to do anything. You could build an API that starts up you can use child process. I forgot if they still call it style underscore process, but you can get child processes, and let me actually just look up whether this is child underscore process. So you can fork other processes from your Node script, and I can say, oh yeah, it is this, and I could say, fork a process, and when forking a process, that's getting essentially within the same state of your current process, fork this other process. So and then you give the module path, and typically you're going to want to spawn a process. So let's not even talk about that for now. So you have this ability to spawn processes. And spawning processes is cool because, let's say I want to make a server that runs llama inference on request, which I'll do in some other video. I want to make a video where I fine tune llama API, and then llama AI, and then I set it up in front of a Node server. So the way I would do that is I don't want to run the inference in Node.js because I probably use Python to train it. So I'm going to spawn a Python process from my Node.js script, right? So that's really cool part of Node.js. I mean, you can do that in anything. You can always spawn processes in most runtimes at high level programming language you're going to use. It's really easy in Node.js. So one of the coolest things about Node.js is that it's super easy. And in my other videos, I talk about Puppeteer a lot. It has really accessible NPM packages for doing fairly complex things, and you can iterate so quickly. Python's great too. I'm not shitting, Python's great. But if you're really 10x, if you're really 20, 30, 40x, then you use Node. Anyone who disagrees, I can't even seriously. That's just not even true. But no, Node.js is cool. So it's one thing to learn. So you should also learn Python. If you want to learn all the things you want to learn to really actually no BS, be super effective right now in the playing field of software development. If you want to be someone that can just at any moment build a product that'll make you a ton of money, learn Python, learn Node.js, learn React and JavaScript. If you know that, insane amount. Learn MySQL, learn Postgres. Postgres is on the up and up. Learn PG Vector in Postgres. Learn about word embeddings and AI. All the stuff that I'm making streams about. Look at my stream when I mess around with word embeddings on my build an AI video. If you want to seriously be super effective And the reason why I say Node.js is that in terms of web scraping, like I would never web scrape not in Node.js. It's so simple because like it's so easy to write. Because look into Cheerio. Being able to utilize the DOM in Node is way better than trying to mock a DOM in Python. Or writing JavaScripts separately and then executing them into your Selenium routine. It's so much easier in Node. And also, when you're learning Node, you're learning how to build web stacks as well that you can put in front of your AI. You know, so like, best things you want to learn right now, genuinely, if you want to be an effective programmer, in my opinion, is 100% get really good at, hold on a second, get really good at basic AI concepts, learn how to use PyTorch, learn how to use neural nets, learn about word2vec, word embeddings. Let me actually make a list. What to learn to be a successful, competitive, not even gonna say successful, to be a competitive, modern software dev. Python, JavaScript, Node.js. Reasons: most data analysis, statistics, and neural networks use this language. Neural networking frameworks uses, like, if you're going to be doing anything in the AI world, you gotta use Python. Learn NumPy and PyTorch and transformers library. Hugging Face libraries. Get really used to using Hugging Face libraries 100%. Sai, listen to this. This is what you need to learn. Just to make it simple, I just want to say NumPy, PyTorch, transformers. Transformers is a pip packages. These are the pip packages for you. PyPy packages for you. Learn JavaScript and Node.js. And actually, let me just say, and React. Learn how to build websites front to back. With React, you can learn React Native and be able to build apps front to back. For JavaScript, learning front end, you will never have to pay anyone for front end ever again. Node.js, oh yeah, so like, let me actually put this out. So you want Node.js and some database, MongoDB, or I'm actually gonna make a clip of this. This is important. This is like more important than the Node.js primer. So if you want to be a competitive modern, if you want to be an independent, an indie dev, that's a better way of saying it. You want to be an indie dev and build what you want when you want to, this is what you should learn, in my opinion. The reason why I'm saying Node.js is because there's so many frameworks that allow you to have speed. Say that again. Node.js gives you speed. This is speed to the market. Understand what I'm saying? So when I'm showing you Node.js, I'm showing you how to, also web scraping, goat. When I'm showing you Node.js, I'm showing you how to get your own data better than anyone else, which is important. And I'm also showing you how to get to the market faster. Okay? And Python Flask can do it too, but I'm saying once you start hiring for people, Next.js, TypeScript, all these things, this is what everyone's training to do. So you should probably position, and it's also very quick, it's very easy, and as we were talking about with its single-threaded non-blocking nature, it's easy to have high performance and entry with Node.js. It just is. People are going to say, oh no, Golang slower to develop. It's obviously faster processing. It's slower to develop. You want to learn, and it could be Vue or Vue. I would suggest only React or Vue, just because Vue is like awesome and React is awesome, and Vue took its fundamentals from React. So, but here's the thing, you know what everyone spends money on? How I make money? Building out wireframes. Building out your designs. That's like, if you don't know how to build out your designs, you're going to be spending money on it. You want to do that, or do you want to build it yourself? Or do you want to at least have the knowledge on how to build it yourself? Okay, and if you have this stack right here, this is the goated stack. This is the goated stack. What's this video's called? Maybe. The goated engineer stack for being an indie dev. If you want the stack for being able to be an indie dev, you have to learn these things. Word to vec. That's in GenSim. Learn word to vec. Learn transformers. Learn PyTorch, NumPy. Not in that order. You should learn PyTorch above everything. You should just 100% vanilla CSS over vanilla HTML CSS over React for fundamentals. Yeah, no, you should. Okay, you have to learn HTML CSS fundamentals. I should be very clear. If you can't do any of this if you don't have fundamentals. Yeah. You have to. You shouldn't do React if you don't have HTML CSS fundamentals. You shouldn't even like touch it, because it's just going to be too complicated. You should be able to make any site in HTML CSS before you touch React or Vue. And then you get into your JavaScript and your React or your Vue. This is the goated engineer stack. So like, if you so here's why this is so important. This is the meat of it. AI is happening. AI is super important. It's not just important in terms of like, plug in Llama 2 and then make $1 million or whatever. It's important because I really should get into this part. So why is this the GOAT stack? So this is why this is the GOAT stack. We started, I said this in another stream, but I'm going to say it again, because I'll make a clip of this. We started with Web 1.0. We're on Web 2.0. We're now on Web 3.0. Now you can debate me all day about this, but I'm telling you, this is the truth, okay? AI is here to stay. It's always been here to stay. And right now, there's very, very high level data scientists, machine learning engineers, people at the tippy top that are manufacturing very large ecosystems to ensure that AI is the future. And I'm not saying that they're successful or not. They are successful because you're using AI right now. Okay? So that's a reality. Web 1.0. The 90s. The 90s time. Everyone was having a good time in the 90s. Everyone was chilling. The web was... The web... What's a good way to put it? There was a flood to move brick and mortar... I can't spell. To the web. Checkout systems. Basic front ends for businesses and addresses, address books. Basic, what's a good example? Basic bulletin board systems, first foray into user generated content. That's the 90s. In the 90s and early 2000s, early aughts, you have everyone's moving towards this new web ecosystem. And you have a ton of people that are discovering that actually this is really good for my business if at any time someone can just look me up and I can tell them my URL and they can actually check things out anywhere in the world. You have email. You have all these systems, this foundation for the web being built. So what happened? The weebs came. The dorks. User generated content. We all in the 2000s, mid 2000s to mid 2010s, late 2010s, we have a situation where people just keep making content. You have the prosumer generation. Everyone is making content and consuming content. Feeds are king. You are now the product. That's what happens. So 10, 15 years of data being created, data coming out. So much data, it's insane. We have a situation where so much data is happening that I actually don't even know where we're at right now with it. We're at a point where so much data has been created that you go to your local, I don't even know, what do people use? Tumblr? I'm kidding. I know people aren't using Tumblr, but it's like there's so much data that people have to make sense of it. Think about how every single day, how many news articles are getting generated every single day. Think about that. I used to work in news companies. And at these news companies, it was crazy the amount of data. It would be like 200 links a day they were pushing. And these are, like the biggest news companies in the country. There's like hundreds and hundreds of URLs getting pushed every day, and you have on those URLs hundreds and hundreds of people commenting, your boomer Karen aunt commenting on Facebook about it every single day. And you have Twitter threads, comments. You have influencers. You have people making videos, like I'm making a video right now. videos every day, comment that's being created every day. This has value to people. This has value to the businesses that we were talking about up here that now find value in the web. So what happens with all that data? Then we have big data. Big data and AI. Let's not talk about AI. AI is Web3. I know a lot of people are going to be like, no, Web3 is blockchain. We'll get to that. AI, and I'll say your identity. That's it. We're now in a stage of the web where we have to do something with all this data. You've posted a ton of things over years and years and years. Your friends have posted a ton of things in years and years and years. You're now in a graph. I've worked at the companies. I know how this works. You're in a graph, many graphs between all these third-party tools, which makes sense that it'd be third-party tools doing this, because obviously Google wouldn't want to have the same internal tool for this that Netflix does. And that's why when you go to, I have a video where I show this, but when you go to CNN, there's like 300 tracking tools, right? Whenever you go to these tracking tools, what they're doing is they're consolidating your identity. This isn't conspiracy theory, I'm just saying what's happening. Your identity and your behavior metrics are being consolidated, and there's a huge ecosystem around what to do with these people and how to locate them and what dimensions we can use to get the right amount of patterns to sell you the products that we weren't able to sell you in the 90s, or we weren't able to do well. This is a resolution. This is a long story of trying to sell you stuff. And right now, there's a war out there for who and how is going to get this data. Who's going to get the data and how are they going to get it? Because right now, you look at Twitter, you look at all these, because those third-party companies, they're not perfect. Netflix is in competition with Google, which is in competition with OpenAI, which is in competition with all these. Everyone's competing over real-world data and how you can map it out in a really good way. That's why OpenAI was such a big, it was like a wrench being thrown into the system, because now you have someone that's actually came around and gotten all this data and actually like made it super small. Like I know it takes a ton to train ChatGPT and all this stuff, but it's actually extremely efficient. You can get like 90% of what Google does for you in an AI model. That's crazy. You think OpenAI is has 90% of the warehouses that Google has? No, it doesn't. So like the power that we're in a phase, this is just to review, this is the reason why this is the goated stack for you to learn as an independent engineer, an indie dev, someone who wants to make value with your code in this world. You learn about Python, you learn NumPy, you learn PyTorch, you learn TinyGrad, transformers, you learn the fundamentals of neural networks, you learn about Word2Vec, you learn about word embeddings. And on the front end side, you learn about basic front end, like how to build front ends. You learn the fundamentals of that, HTML, CSS, you learn React, you learn whatever, you pick a framework, get good at it. So you don't have to pay people to build your front ends. Or you can at least have the mindset to know what to pay people, right? You learn Node.js. You don't need to, you can do Python Flask and all that, but I suggest you learn Node.js to build your backends for speed to the market and also to have access to those top, the new, there's like a million people in coding boot camps learning Node that are going to build your product and help you build your product. And also, in my opinion, I would always argue Node.js Puppeteer setup is the best stack to do web scraping, which is the foundation for how you can gain personal power in the Web3 era that we're entering. AI is reinforced by real-world data. You have to know how to get your real-world data. You have to know how to make use of it. You have to know how to train these models. Even if you're going to use Llama 2 and you need to learn how to fine-tune it for your purposes. Because your identity and how it's the patterns that are being used to place you. And also, when you use Yelp, when you use Google, when you use LinkedIn, when you use all these services, your identity and the patterns in which you are behaving and other people are behaving is going to be the foundation of it already is, but it's going to be the foundation of our economy at an extreme level in the future. And there's already talk of this stuff. I'm not even being a conspiracy guy. There's already talk of this stuff happening in the government level of like how people vote, and happening in the, you could see it in Brovid or whatever. You could see it in how the medical world is operating, where maybe people want to start IDing you, you know? I get it, I'm being a conspiracy guy, but I don't know. I do know. But it's super, super important to know how to get your own data and to be able to, be the one to build the right products, to not do any of that stuff. That stuff's crazy, but to actually provide value to the market. Because the reality is, when I talked a little bit about this on a podcast earlier with my buddy Jack, is that all these top-down things to try to get all your data, and you have like Facebook and like all these companies like coming together to try to get your data and do all this, they're not good at solving your problems. But they have to fill a gap in the market. They just kind of have to. That's their role. So you should, as the common man, be looking at your around and saying, oh, I think AI could be used there. I think I could automate this business. I could do this. I could do this. And you build it. You don't offload it to AGI. You learn how to fine-tune your AI model to address your real-world problem. You build it. You build the front end. You build the full stack. You push it out. You figure out how to build, and then eventually you gain that independence because you know everything that you need in order to get done, in order to get to the market. And also you make money along the way. So that's the reason why I think this is the goated stack. That's it. And so this is a little tangent, but overall, if you want to learn, the reason why I'm teaching Node.js is that if you want to learn how to really be that 10x, 11, 12, 13, 14, 15, 1000x engineer, you gotta learn the fundamentals of the you gotta learn how to sneeze. You gotta learn fundamentals. And when you're seeing me code in Node, you gotta learn how Node works. You gotta know why it's important. That's it. Have a good day. Like, subscribe. If you're still here, that's insane. That's crazy. Good job. What about Java, C++, and those kind of languages? Do you think they're relevant nowadays? That's a big question. So it's not that they're not relevant. they're definitely relevant, especially C++. If you want to be a game developer, you absolutely should learn C++. If you want to do a ton of things, you should learn C. I mean, it opens up the whole world of processing and embedded systems as well. Learning C++, learning C. You should always learn C because that's where the fundamentals are. The best way to learn about memory is to learn C. Notice how I didn't talk about Java? I don't think you need to learn Java. But at C++, yeah, 100%. I don't think Java is necessary right now. The reasons for why Java was created was addressed by Python and the entire full stack web dev advent. Golang. There's no reason to learn Java, in my opinion. Java's a headache, and you're going to be typing so much that you're going to miss out on your life. You're going to miss out on your child's birth. Learning Java. But C++, yeah, there's a ton. I mean, C as a foundation is just, yeah, everyone should do that. I'm saying, like, this is, like, efficient. So, you didn't sacrifice 3 years of your life. I'm being, like, fairly dramatic here. I'm being fairly, no. I mean, I'm just saying from the perspective of someone, like, I was answering as if this is the first language you're learning. If you already learned Java, like, I would suggest lean into Java if you have 3 years of experience in it. Thing is, you can do a lot of this stuff in Java. The drawback of Java is a lot of people aren't going to be building interesting things in Java in the next 5 years. That's a reality of Java. But people are going to be building interesting things in Rust and Go. And if you really want to learn a systems language, I would suggest learning Go. Yeah, if you're if you're already doing Python, then that's awesome. Like, Python is, I mean, you shouldn't only do Python, in my opinion. I do a lot of Python because it's like, it's easy for me to transfer a lot of ideas into Python right now because so many people are making Python. Really about what? About the Python? Yeah. If you're using, really about what? Yeah, I think Go's great. Yeah. I think Go is I would pick Go as a foundational language for server development. Mostly because concurrency is such a foundational, it's just, concurrency is so important. Like, half of the stream was talking about why Node.js is optimal for an entry level to concurrency, but Go is built for it is actually a language built for it, and not just like adapting. Like, JavaScript's convenient for concurrency because of the single threaded non-blocking thing, and it's single-threaded non-blocking because of the fact that it was written for the browser, which has to be non-blocking for the render engine. Go is concurrent by, like, nature. Honestly, yeah, I think people are, I mean, I don't even just think, a ton of people are moving to a Go Postgres backend. If you learn Go and Postgres, yeah. Oh, if you thought about it, if you thought about it, do it. Go is a good bet. Go or Python are both good bets. Like, Postgres is probably like the best database you could learn right now. Yeah, I would say, yeah, learn Go. Postgres is probably the best database, and there's so many Go Postgres setups. Like, I think I would say stay away from Java, in my opinion. I just don't see any action going towards Java. Like, there's Java jobs, in industry and in government that are like older, but I don't think you're going to see a lot of that in 5 years. I think you're going to see a lot of Python and Go and Rust. 100%. People are already moving towards Rust and machine learning. I mean, it's super new, but yeah, I'm not an expert on whether it is literally outdated. I just know it's not in the ethos. I just know it's being phased out. Like in terms of like people push, like industry people pushing for it. I know Java's getting obliterated by Python and Go and Rust. Rust. I've been learning Rust a little bit. Tony in the chat was like talking about how he's like, yeah, man, learn Rust, and I've been learning a little bit. I like it. I suggest maybe learning C first. You should probably always learn C first, just so you can learn about stack and heap, and you can learn about pointers and allocating, because Rust optimizes pointers in a way that's great, but it's just like you kind of should know why it does. So I would say maybe like spend a few weeks on C before Rust. But I'm trying to learn some Rust. It's hard to manage with all the 10x coding. Yeah, no, I just think if you pick like Python or Go, or like JavaScript, you'd be very wary of just learning JavaScript, in my opinion. But if you pick Python or Go, like, and you learn like a framework with that, like that's a good stack. With this, I'm saying like this is my stack for like you want to be goated. Or like you want to be like an indie dev. You want to be an independent developer. But if you want a job, this actually is this is good for getting a job. But if you want a job, I think pick Python or Go or Rust and learn a framework and get really good at it. My problem with Rust is it's just useful for yeah. If that's the way you feel about Rust, don't do it. Yeah. The people that should do Rust are people that want to do systems. Yeah, you can't get a job outside systems if you're doing Rust. There's no way. I mean, I don't think there's any. I'd have to look into it. I don't think there's any jobs for like sort of off topic. I think earlier you were talking about specific models in AI as opposed to general language modeling. Could you elaborate on that? What does that mean for the future of AI? Oh, interesting. Yeah, so yeah, most of my personal research now has been on AI models and like trying to. So right now what's happening in the industry is they're trying to go toward the AGI. That's really, that's the underlying. I know that seems like that AGI is such a like meme at this point that they're gonna have this like super model, but that's what they're trying to do. That's why everyone's just like hunting down for A100s and just like it's just escalating. The future in industry, and this is from, which I'll have him on again, my buddy Matt, but this is from like conversations my buddy Matt, who you can look him up, but I won't say his like background, but he's a very high level machine learning guy. My buddy Tony, who's an AI researcher. A lot of people, well, I don't want to just list names, but like from my friends that are AI people to myself to people I know in the industry, a lot is going towards smaller classical machine learning models to reinforce a lot of the big like generative AI models. So pretty much instead of just doing transformers for everything, so transformers requires a ton of compute. That's one. So the cool thing about transformers is that you can scale it in parallel. So attention, the mechanism behind everything you see right now with generative AI, So like ChatGPT and all that stuff, the transformers is the bedrock of all that. And the interesting thing about that is that with attention, which is this, you should look up how attention works. If you want to know the fundamentals on AI right now, just look at Andre Karpathy's GPT from scratch video, and like I watched that like 5 times. That's super important. And look at the attention mechanism. So the attention mechanism is set up in a way that allows you to run things in parallel, which is great. It allows you to train these models with crazy amounts of batches, and a batch is something where it's like you have your data set and you can run things. If you have like 8 batches, you can like run 8 at the same time, 8 of your whatever it is at the same time. And the cool thing about that is that you can get things done quicker with more compute. So that's why there's this race towards GPUs right now, is because transformers are blowing up because it's the best way to do generative AI. It's why ChatGPT is so powerful, right? But the problem with a lot of that is compute doesn't scale for 90% of businesses, and people are seeing that the power of this, it addresses a lot of their problems in their business. And you have people spending like X amount of dollars on OpenAI keys, and then being like, okay, I have these OpenAI keys, I'm gonna get OpenAI embeddings, and I'm gonna embed my financial services let's say I'm a financial advisor, I'm gonna embed all these documents I had from OpenAI, and I'm gonna like make it easy for people to find my information over the years and all that. Turns out that video I did with the Word2Vec model for that case I just mentioned with the financial advisor, that like make your own job AI thing, that would address that same problem at a model that can run on CPU inference. Just so basic Word2Vec model. So when I talk about specific models, and I talk about like smaller models, I'm talking about that. I'm talking about using smaller, simple, more classical machine learning models to solve a lot of these bigger problems, rather than and you can just use transformers, but simple transformer. That's why I look into word embeddings, because word embeddings, Word2Vec, think word embeddings, being able to create really good word embeddings from your own data set, so data that you know how to manipulate, you'll be able to, let's say you have a business that's like, hey, I'm a law practice and we have like 500 textbooks that we have to like look through in order to solve our cases. I want to make a really easy an easy search for that. It's like, maybe you don't need OpenAI embeddings. You can just train your own model from that text. But I think we wouldn't be seeing more programming language pop up like this decade in the future. So what are the programming languages that you're betting on besides Python and JavaScript? I think if you want to make a bet on a language, you got to bet on Python. JavaScript has to be used. It has to, because we have to use the web to some extent. But think about this. You really want to think ahead. So we're doing second order thinking here, right? This first order thing is second order thinking. Let's think of the result of the result here. ChatGPT is opening up the fact that UIs, we hate UIs. For most of our problems on the web, we actually don't even like UIs. Think about how many people are just asking ChatGPT a question, and the UI is just text feedback. You know what I mean? Like, I would say, I think there's going to be less complicated UIs by far in the future. And I think a lot of front ends with generative AI, a lot of front ends are going to start to get automated with code. I'm even training some models to make it easy for me to write HTML. And I know a ton of other people are. And I know GPT-4 can do it pretty well, but that's another thing. if we make a specific model to train HTML, maybe you don't need GPT-4 to do it for you. Maybe you can run it on your computer for free, right? That's what I'm saying with specific models. But while that's happening, I think you're going to see a lot less people genuinely writing front end code in 5 years. And I think so. I would bet on Python, because the things making sure that happens is going to be Python related. It's going to be people writing AI models in Python, people, and like I like to scrape data in Node.js, but like most data scientists use Python to scrape data. So like I like it for Node.js. I think I like Node.js, but it's not. That's my preference with it. I think industry wise, you're gonna see. I would bet on Python over JavaScript any day. Any day. I think JavaScript. I think Go actually has more longevity in terms of making money writing Go than JavaScript. What open source models are you using for your embeddings for free? I tried Hugging Face Instructor embeddings and it sucked. I use sentence transformers, and I load up models with sentence transformers, which is another Hugging Face library, and I embed everything with that. So there's some good question answer models with on Hugging Face. So like there's I forgot what it's called. I think it's MPNet. There's a few question answering models that are really cool. If you want to have question answering embeddings where you get the dot score from the question and the answer, and then some of them are cosine similarity. A dot score is going to be better typically for those, but so yeah, like I would say sentence transformers is how I'm getting embeddings right now. If you're using Hugging Face, that's a pretty good package, but also Word2Vec. So if it's just from scratch and I have a data set, I get Word2Vec, and then or Doc2Vec. Actually, like Doc2Vec, it's very similar to Word2Vec, but it's, as you can guess, it's document based. So it's rather than vectorizing specific words, you're vectorizing documents. So it just adds a layer, it adds a paragraph vector to it. Look up Doc2Vec and Word2Vec. Like that stuff is this smart, and this is all from like I've been spending like 90% of my time self-learning machine learning the past year, and I've been just like fired because I'm traditionally like a software engineer and not machine learning, and my buddy is like super smart and an expert. Oh, thank you. Yeah, anytime, Reed. But yeah, my buddy, who's like super smart at this, I toss him so many questions about this stuff, and I'll get him on the stream again. Me and him had a interview. You should check out that interview if you're interested in this 100%. It's it's Matthew Finch. Look at that one. So like he will die by word embeddings. Word embeddings is super important in the way he sort of looks at machine learning, and I've grown to sort of see that really at the end of the day all this stuff is just matrix representations of data, or representing data with matrices, and your ability to represent data better and better and better through all this training. Like at the end of the day, all the transformers does is it's a distributed hash table for words, for tokens. And that's all it is. You're just training something to represent tokens. And if you train in a decoder, so you have GPT, which GPT is a decoder transformer. So all it's doing is it's using top K, which is like this algorithm. It's like the top whatever amount of possibilities, and there's a way, and then they have like this distribution, the softmax to function to figure out, to make predictions on which word to say next. That's why ChatGPT is so smart, is that it was trained on billions and billions and billions of different documents, and then they found the perfect representations of these words, these matrix representations of the words, not perfect, semi-perfect, and then it's predicting the next word using this top K. Well, I'm assuming top K because that's one of the things you send up to OpenAI, but it's generating the tokens based on these previous tokens, and it's just decoding. That's decoding. It's all that's happening, and it's all just matrix manipulation. It's all just predictive. It's predictive statistics. So it's just you know what? If you mess around with really, the best thing you can do is go to Hugging Face's, start with PyTorch actually. Look at a transformer implementation in PyTorch, which, like I said, Andre Carpathy has one. You look at that, and then you'll be able to really see how it's working, and you'll be able to see how the generate function works. Because that's really like what actually is the thing that you should understand. You should learn the forward pass, so you should learn how attention works. Key, query, vector. I should really do a whole stream on transformers, but you should look at key, query, vector, and transformers, the forward pass. So forward pass in AI is just like it goes through the kernels. When people talk about parameters, they're like, oh, everyone just says things now. They're like, oh, ChatGPT has 175 billion parameters. What that means is the weights. So it has 175 billion little numbers that these neurons are adjusting over and over again as it does backpropagation to learn the representations of all these words. So before I go to sleep, what you think about Angular? Angular is I never took it that seriously, because I actually learned, because I've had some front-end jobs as well, mostly like React and Vue, as well as like the back-end stuff, and Angular, I never had an Angular job, so I can't like crap on it or anything, but whenever I look at Angular, I just wince, because it just feels so unnatural. I don't like anything that you have to do a lot of I like the fact, here's the one thing I'll say about Angular, I like the fact that React commits to JSX, and the reason why I like that is because you just know you're using a totally new language, and I don't know much about Angular, but React hooks is so simple, I don't even know why you would use anything else. And this is something I like Vue, and I like all that, but like React hooks, as soon as that came out, I was like, I'm not using anything else. I just like the fact that you just in JSX world, it's very simple. Angular feels too, like, I don't know if they changed this, but it originally was so based on data props. It was so data prop heavy that you would just like, it would just be like, there'd be like a billion data props on each element, and it was like, well, this just looks confusing. So in terms of job, no, just to learn React. So many people are building React apps for their businesses. Like, there's no point in, like, you only have so much time in a day. Just learn React, you know. What's your opinion on React.js and native's longevity? I plan on learning the framework and intend to get an internship. Oh, React has so much longevity. The trick is, Caden, the trick is, how fast can you get good at it? That's the really only trick. Companies are going to be using React for the next decade, in my opinion. Whether or not all their React scripts are generated by GPT-4 or a 10. You know, whether or not that happens, I don't know. But I know I can tell you one thing, it's going to be used for a while. You just need to get good at it fast. What's your background? Do you have like a background? Because if it's fine if you don't, but if you do, then you should definitely, I would say, commit. If you don't, then I would say think about what your plan is. Here's the thing about, because I mentor people with like getting a job and new engineers and junior devs and all that, and I'll do a stream on like a Q&A stream where I just kind of answer questions about this stuff. But so the thing is, if you really want to like from nothing right now learn React, you have to be crazy good in a short amount of time. That's how competitive it's getting. I teach people all day React. I'm not every day, but like most this past year, I quit all my contracts so I could self-study, and I've been teaching to make money, like doing private lessons, teaching people React and teaching people Node and like all this random like SQL and random stuff. And I'm telling you, so every single bootcamp has the same stack. It's React, Mongo, Node.js. You know, like it's all Express. It's the Mern stack or whatever. And really think in terms of longevity of that. It's like, okay, you're gonna have a ton of engineers in the same field, all in a block of like 5 years, getting like thousands and thousands of engineers getting trained in the same thing. That's extreme competition. So long story short, like if you want to do that, do it, but you're gonna have to get good really fast. You're gonna have to like hustle, you know, and like you should love it. Like I would say, if you love making websites in React, do it. 100% do it. Like if you enjoy, like think of projects that you get you excited, you know, and just keep doing them over and like code every day. You see how I code like every day, like here, like, and I'll just like you gotta code like every day if you want to be competitive to get those jobs. That makes sense. Well, I've been interested in the field and plan on going to school with CS, but I would like to learn the front end aspect by the time to go to school and possibly an internship. Oh, okay. So you're like late high school. Yeah. So if that's the case, then yeah, if that's your, yeah, do it. And that's actually smart. That's actually smart that that you wanna prep before school. Oh, you know JS and HTML and CSS currently? Oh, great. So you're in a perfect situation. You're in a perfect situation. If you know that and you're about to go to school for CS, by the time you're done your school in CS, the fact you've already learned JS, HTML, and you're already about to learn React, you're going to be crushing. So does your school start in like September? Like it's July right now, so you have like a month or whatever to. If you spend this next month getting really good at React, you're gonna be super set up, because you're already. I thought you were starting from nothing. The fact you know JS and you're about to go to CS school, if you really get good at React in the next month and like make a lot of projects and just like every day hit it, by the time you get into CS program. Oh, so your senior year in August. Oh, okay. Yeah, so throughout your next senior year, oh, great. So in your next senior year, if you get really good at React, you'll be able to do freelance, and you could fund yourself as you're in school. So like that's the one cool thing. Yeah, definitely do it. Just do it. Yeah. Wait, what's your plan? Do you want to get like be a front end, or do you want to be full stack? Do you want to be just like a systems guy, DevOps? Do you want to do mobile sites? Like, what's your plan with that? Because like, one thing about all that stuff is you should be pretty focused on in terms of what you want to do in the end. You should be really focused, actually. Like this is a time for you to be focused on, like, because you're about to finish your final year, you're about to get into the workforce, you have a lot of different pathways to go. If you find a focus now, and you already seem precocious because you're trying to learn React, and you hone in on that focus, whatever it is, by the time you get internships, it's gonna be like so simple, because like so many people are lazy. You probably don't fully understand the grasp of like how lazy the average person is when it comes to software engineering, or when it comes to engineering in general. Do the work outside of school, and you'll be so surprised how little people do it. You'd be so surprised. But yeah, tell me, what's your plan? What's your like what type of job do you want to get? Because you may not, if you do want to. Oh, embedded programs with Lua. That sounds like something you did in your college course. Embedded systems with Lua. Whoa, was that like robotics? That sounds like a robotics thing. I used to love Lua. That was the first language I learned for game programming that made me feel like I was actually making games. That was like, I had like a summer in high school where I was learning Lua, and I loved Lua. I don't know anything about what people are doing with Lua now. But that was probably the first time I was like, oh, I think I can make games. Yeah, I think if you want to be a full stack, watch this whole video. When I talk about so many important concepts for full stack. It was game development, and then I grew into absolutely hating it. Yeah, people don't teach game development well. I find game development, it's the love engine. If you really like, were you guys using the love engine? Because the love engine for me was like, that was when I just like got game development. That's when I was like yeah. It was like Love Engine. Is that still around? Because this was like 10 years ago. But yeah, like, yeah, okay, full stack. I would suggest watching this. I'm not just to push out my content. I literally just did a full stack primer in Node.js. So like, if you wanna, Size got my back. He's got my back. No, this is because I talked to a ton of people training to be full stacks in these boot camps, and like, I'm telling you, there's like such a gap of fundamentals. If you want to be a full stack, I would say honestly, don't even touch React at first. Don't even touch React until you know. Like, learn PHP and MySQL before you learn React. You really want to be a full stack? Like, hey, thank you, I appreciate it. Yeah, I mean, please watch the video. I go through everything you need to know about Node.js. You can skip the JavaScript part in the beginning. I'll annotate it with I'll annotate the video once I finish streaming. But yeah, you don't. Yeah, in terms of like full stack, really like pick up Node.js and SQL. or pick up, it doesn't need to be Node, pick up Python and SQL. Python, SQL, Node.js, SQL. If you do that, if you pick up a framework like Python, Flask, SQL, I say SQL because SQL is a lot easier to learn than it's a lot more fundamental. It's not easy to learn. It's a lot more fundamental than if you go out and you learn MongoDB. MongoDB is great, but SQL is going to give you fundamental knowledge about data and tables. If you want to be a full stack, don't even, I know that it seems like that's the entry, but I learned full stack I learned PHP when I was 14. I learned PHP, MySQL, and all the JavaScript stuff was just it was obvious. I was like, okay, well, obviously this is how this worked, and I would just do JavaScript jQuery for years, and then when did I learn framework? When I was at the first time I really did a framework was on some internship. This was or when I was 19, 20, when I was at the New York Times. They were they taught us React because they were rebuilding everything in Node and React, and I was like, this is fine, but I did vanilla JavaScript for 6 years at that point, but it was all just, I started with how does sessions work, how do cookies work, start with that. Start with how sessions work, how cookies work, how HTTP methods work, or what are the HTTP methods, how does HTTP work, look at this video, look at everything I break down with Node.js. These are fundamental things. I walk through it with Node.js, but I talk about a ton of fundamentals. I would say if you really want to be full stack, don't even touch React after you do all that stuff. Learn the back end first. That's what you should do, in my opinion. I think people do it wrong. They learn the front end and then they're they don't understand, because back end is actually the engineering. The front end isn't even there's not even much engineering. I mean, no, there's a decent amount. There's more over engineering in the front end than engineering in the back end. Does that make sense? Is PHP a requirement for database? No. Database PHP is just like Node.js. It's a runtime. In a language, it's in PHP. It's its own language. It's separate than JavaScript. These are all JavaScript Node.js is more akin to Python and PHP than anything else. It's just it's an environment for you to write web development oriented code or server code in. PHP, if you want to do database queries, you just use SQL. So the way SQL works is you get a server. So you get a SQL server, you get Postgres server, and this is your database server, and you run this locally, and you'll use a language. Look up an ORM. So an ORM is an object relational mapping. This is something you're going to use in your programming language to make queries to your database server. Does that make sense? So it's sort of when it comes to, I know it can get confusing because it seems like everyone uses PHP, but the reality is PHP is just a language that was made for web development. Keep them coming. I can explain stuff all day. If I don't know something, I'll just be I don't know. But for this stuff, I got years. Years of this stuff. Yeah, I would say, let's see, I forgot. Yeah. I want to be full stack. It's so funny. I trained so many people to be or this past year I've been like training so many people in like in charge of web user. How do you see online writing, especially with short form videos taking over? Interesting. That's a really, really good point. Sigh. That's like, it's like what happens when GPT becomes normalized? That's actually a really good question. That's a really good question. Like, I think what's probably gonna happen is, well, one, people aren't gonna trust writing. I think that's my first thought. I think that, and also you got to think if that can happen with writing, that's also going to happen with, so like, and I'm talking about the AI piece. If AI can automate most online writing, then it's probably going to automate a lot of videos eventually, to a high degree. I don't think online writing is going to be at all a good way to. I think the one thing about short form video is good for casual entertainment, but if anyone really wants to understand information from something, they need to have text, and that's just how brains work. I mean, someone can argue with that, but like, I think short form video is great for feeds, it's great for scrolling, but at the end of the day, people are always going to have to look at your terms and conditions, look at your privacy policy. You know, it's very easy to scroll down, to move to different sections of content with text, whereas video, like, think about it, it's like short form video is blowing up and video is blowing up, but how often are you looking at text in the YouTube chapters to get to the section of the YouTube video? You know, like in terms of like moving around videos, text is still king. So text is always going to be around, but I think generative content is going to blow content writing out of the water. I don't think anyone's going to get paid for content writing in the future. I don't see how that's going to happen. I don't see how that's going to happen. Yeah, like I don't know. I mean, maybe some people. I don't know. I doubt it. I highly doubt it. Maybe videos are gonna. No, educationally, I'm thinking about like I never actually watch. I sometimes watch videos for education, but very rarely. Like that GPT video. So like, since content writing is information focused, AI will probably override. Yeah, 100%. Anything informative, I think AI is gonna take like 90% of it. Like making a React tutorial or something. But in terms of like nitty gritty, like you're always gonna have white papers. I do think this funny Twitter account mentioned how like in the future generative AI is gonna supplement a lot of white papers, and I think that's probably gonna happen. I think a lot of white papers are gonna be kind of like you use AI to navigate like the white paper. It almost like gives you a step-by-step kind of tutorial on the concepts. Maybe it's like the white paper, it gives you the top 3 big foundational concepts about it first, and then it breaks down each concept, and then it gives you the actual white paper. So it's like you can maybe ask the white paper, oh, I'm a beginner, and as a beginner, how do I walk through these concepts? And then it walks through if you're a beginner, or if it's like I'm a expert, can you walk me through these concepts before? So it gives you something to read before you read the white paper. Because sometimes reading white papers is challenging. Think about how important of a problem that is to solve. So if any engineer has to read a ton of white papers for entertainment-centric content, if eventually models are going to be trained on high-performing content to develop funny memes, short videos, what's the future for creators in a decade? Interesting. So that's the thing. I don't think AI is that funny on the front end aspect until towards the end of senior minor. Oh, you want a minor in data science and in mathematics? I would say just go in with an open mind and just be super curious. Okay, and just be super curious. That's my best. Don't even think too much. People always stress so much about their college degrees. Just be curious. Just be the most curious person in the room. Try not to be the smartest person in the room. Be the most curious person in the room. Smartest people I know are the most curious. Just like it's a game. I'm telling you, all this stuff. You're gamifying it. But yeah, I think so. I don't think AIs can be funny. Like I think they can be irreverent. So I think they can say oddball stuff, but I don't think they can actually be like funny. I don't think they could be that creative. Like even if you look at stable diffusion things, the interesting part about it is the idea. When you look at those like things where it's like, I saw one where it's like a bunch of jacked people from The Office. It's like a living man. That's the mindset. That idea in the living man is the thing that told the AI to do that. Will we get to a point where we can tell AIs to think of funny concepts? Maybe. I think so, probably, but I don't think it would. I think it'd be like a ton of processing for something someone can just do, and like I could just think of a funny concept in a second. Like, what if you had like Dragon Ball Z but Barbie edition or something? It's like, oh, like could ChatGPT do that quickly at a degree that's like in order for GPT to do that, it would have to be so much processing that it's not even like worth it. Haven't developed a passion for it yet, though it's getting quite interesting with its potency, so it's definitely something for me to explore in the future. Yeah, like just follow your passion, that's it. If you see yourself identifying with something, like if you're like, I want to be X, follow that. Whatever you're going to wake up in the morning and identify with and that's powerful for you, just do that. You don't have to do anything else. So if you're like, I wake up every day, I'm an entrepreneur, I build businesses, I'm an AI engineer, like label yourself something that's valuable and don't let anyone take that from you. It's like, I'm a coder. It's like really identify with it, and then because this one therapist, not that I'm not big into therapy, but this one person I respect, they were saying how it seems like there's a very high correlation with depression and a lack of identity. It's like a lot of it's like it seems like a lot of patients can be really a lot of the person's patience, their first step to getting out of depression is just doing an activity they can identify with. So think less about the market with whatever you're trying to do, and think about something, a work you're going to be proud of. Not to get too, I'm not trying to get too hokey here, but, it's where possible for AI to displace creators. Shouldn't policymakers get ahead of it? We would just adapt as we... Oh, it's interesting? You want to hear some real sauce? It seems like there's already going to be some generative AI policy stuff, which is terrifying. So kind of like looking at our metrics and being like... that's what I was talking about. The Web3 here is, your identity is very much a result of this Web2 phase. You've been teaching, you've been like, with your data over the years, in my day, everyone, we've all been teaching the AI to sort of like, we've been kind of teaching it to know so much about us that they'll be able to build the next wave of, I know it sounds conspiracy theory, but control mechanisms. So like, and I know this sounds crazy conspiracy, but look up Gov AI. This is already a project happening where it's like an AI it seems like an AI that can sort of generate policy. That's my first initial thought on it. Someone else should do research on it. I don't want to make too many claims, but in terms of AI to displace creators, I actually don't agree with any policy solutions for AI and creators. Like, I actually don't agree with that. Like, I think AI, if there's some sort of policy based solution for the progression of AI, it's just gonna hurt indie devs. Because think about like OpenAI was already in talks with the government in order to think of solutions to control mechanisms around AI. That's a big Microsoft based company. Like I promise you, whatever solutions they think of are not going to be everyday man solutions. It's not going to be like, these are going to be things that it's in order to, for instance, maybe it's like you have to make some API request or whatever to tag your data with the proper things. The type of data coverage you'd need that they would do, it would be something that only big companies can do to cover their ass in order to train their AI models. It would be something that's like super, like you have to like authorize your company through this, like this centralized agency has to look at your data sets before you train them. You know what I mean? Like right now we're in the Wild West and everything's great, but I think we're gonna get into a world where stuff like that starts happening. It's gonna suck. It's only gonna be like Amazon and like Microsoft being able to cover their data. I don't think that's gonna be good at all for the future of. That's what I'm telling you. Like right now, learn how to get your own data. Build businesses around it. Like gain independence while we have the time. Like we have this AI gold rush. Get your spot, and the more tools we build in the open source community, and the more people get educated on how to build stuff. Yeah, I think the better. Because it doesn't have to suck, but I think any regulation that happens is gonna hurt the little guy. Definitely. There's very few times regulation hasn't done that, has helped the little guy out, and that stuff happened like 100 years ago. Consumer CPA laws were not bad, or consumer protection, not CPA, consumer protection agency stuff. That was okay, I guess, but in general, I just don't think there's a lot of. I'm just not a big government guy. Any more questions? I'm gonna head off in a little bit. I'll make this the QA section. I gotta make chapters for everything. I gotta really. This is a long one. This is a good one. I feel like I covered so much cool stuff in this one. Any more questions about stuff? I don't know how far back. I'm like delayed by like a minute, I think. Yeah, of course. Of course, guys. Anytime. I should just do like a whole QA stream. Oh wait. Wait. What do you want me to stream next? Because I have some ideas. I have some interesting things to build. I got a big one coming up soon. I got a big one. If anyone has any ideas, let me know. You could let me know after in the comments or whatever. That's alright. Alright. It was fun. Fun while it lasted. I'll see you guys. Primers for vectors, transformers. Yeah. I'll do a transformers one. That's what I need to do, a transformers one. And I need to break down the from scratch transformers code and just break it down, because I think that's a really good idea. I gotta do that. I gotta put that in the pipeline. I got a fun one though. I'm not gonna say it, but I'm gonna build something kind of fun soon. All right, see ya.